6/9 now. Didn't make any mistakes. Hey folks, welcome, and hey, happy 4th of July. We are so glad to have you with us this afternoon here on TN Learn's Mathline. We're in summer school, although you know, everybody seems to have a holiday and take a day off on the 4th of July, so hey, summer school's here to have fun with you, all right? We're going to have a light show today, one that you can sit back. I don't even think you maybe need to get pencil and paper, but you know, if you want to, grab some. Work the problems along with us today. But I'm Ernie Roberts. I'm your host for today's TN Learn Mathline Summer School 4th of July edition. Let's see what we've got going on today. I bet, hey, we're going to celebrate the 4th of July in summer school. And you know what? What better way to celebrate the 4th than let's talk about the number 4. All right, let's see what great things we've got in store today for the number 4. All right, so let's see what our first situation is. What we're going to do, we're going to first just kind of explore this number a little bit. All right, what does the number 4 have? It's got some factors. Oh, we could find a lot of ways we could add up to get 4. I mean, those are kind of go on forever and ever. But the factors of 4, we're thinking of integral factors. All right, we're looking at the integers there, and there's not a lot. There's not a lot. Let's see. We could pick up. Ooh, let's see, how about it? 1 times 4? By the way, 4 times 1 means the same thing, so let me pull that out a little bit. There we go, 1 times 4, or 2 times 2. There you go. Those are options. So if we want to give the whole set of factors of 4, we're going to have 1, 2, and 4. Now I'm going to tell you, we start counting up numbers. When we count up the number 1, it only has 1 factor. 2 has 2 factors. 3 has 2 factors, which are 3 and 1. This is the first number that actually has more than 1 set of factors, all right? Because we're thinking with 1, we had 1 times 1. We had 2 times 2 for 4 here. And we also have 1 times 4, which will give you 4. By the way, 1 and 4, those are your perfect squares, first 2 perfect squares. So some really cool stuff going on here with the number 4, all right? Also, it's been part of our language. When we hear the word quad, usually we're thinking of things that are involving the number 4, all right? Quartering, number 4, those kind of things. So we do find it very important. Now, by the way, how many quarters make a dollar? 4, all right? So we've got a lot of ways that we're going to put the number 4 into business today. Now, set of factors, those are all the numbers or all the integers that are divisible into that number 4. So that's pretty cool. Now, prime factorization. I always like to play that little thing like a factor tree here. We've got the 4. And we take the branches off of it there. There are not many ways this is going to work, all right? I mean, 1 times 4 doesn't help me any, right? So in this case, it's going to be 2, 2, and you know what that simply gives me? That gives me 2 squared. Now, I know I mentioned a minute ago, 4 is our first perfect square after 1, all right? 1 squared is 1, then 2 squared gives you 4, and that's where some things begin to start happening. Also, when we take 4, it's basically if we split 2 in half, we get 4 pieces. And we get fourths, okay? Or we get quarters. We get things of that nature. So we use that number 4 quite a bit in our world. And it's a very nice number here with all the factors, considering it's the first one, like I said, that gets more than just 2 factors as you start counting up the ladder, all right? And it's certainly not a prime number either. It's a very composite, all right, as it has more than 1 run to go. Now, let's take another look at a situation here. It says, let's flip 2 coins, all right? So we think of a coin that has either heads or it has tails, all right? Got one or the other. And it says, how many outcomes with heads and or tails, all right? So in other words, we flip 2 coins. And we got coin number 1. I'm going to put it right over here. Here's number 1. And here's number 2. We usually think of them fairly kind of round, so we'll make them kind of look like they're a little bit round, okay? So here are the results. My first one I could get, how about it? Get a head on that, and I could get heads on the other one. So I get 2 heads, all right? So there's my first option right there. There's one possibility. All right, it says how many outcomes? That's one outcome. That's one option, would you say? Let's say the first coin hit head again, but this time we got a tail on the second one. So now we're up to 2 possibilities, okay? 2 possibilities. Well, you know what? If I hit heads here, I've already used all my possibilities, haven't I? So let's let the first coin now take on the tail. Put on a tail in there, all right? Put a big T down there. Tennessee, right? T, here we go. But that's about tails on this side, okay? And that would make tails, and then we could get a head on the second coin. And then, you know what? We could pick up a T and a T, two tails. And you'll see what's going on. The question asks what? How many outcomes? I have 1, 2, 3, 4. Oh, it's a big old 4. All right, 4 outcomes on this one, all right? And that's coming from the fact also back to the minute we just used a minute ago. That's what 2 squared will do for you. You say, what do you mean 2 squared? 2 outcomes, 2 tosses. That's what we're going to say, all right? So it's 2 to the second power. You say, well, what would happen if we did 3 coins? We can get 4. But we would have 2 to the third, which would give us 8. We could play that game on, up, and down the ladder. But you know what? Today it's all about our lovely number 4. All right? And we'll do another show on probability sometime along that way where we flip some coins, we roll some dice, and we do all some other great things with some basic probability. All right? But for today, it's all about our number 4. All right? Yeah, let's see what's got. Our 4th problem coming up. Maybe our 3rd problem here. What coming up? It's going to say solve 1/4. Well, there's another 4. X minus 4 equals -3. All right, so we're going to solve for x. We're going to look quick equation here. And notice we've got this 1/4. So be sure we write it as 1/4. And the x, we'll attach it kind of there in the middle. Bring it up a little bit. It's not 1/4x. It's just 1/4 times the x. And we're going to subtract 4. And we're going to pick up a -3 when all is said and done here. All is said and done. Isn't that exciting? Everybody's exciting out there. Rah, rah. Shoot off some fireworks while we're at it, by the way, okay? Now, let's see where we're going to go with this thing. We are going to remove this 4. I'm pointing at it. Everybody see it? We're going to remove that by adding 4 to both sides. So let's go with it. We're going to celebrate this thing. Because I add 4 to the left. You know the game. You got to add it to the right. The addition property of equality demands that. All right. So let's see what we end up with. We lose our 4s. Say goodbye 4s. Bye 4s. But we pick up something different over here. It looks like we're picking up a +1 because the -3 plus 4 gives us that +1. All right. And we still got this 1/4 to hang out with over here. 1/4 of x. Now, at this point, you got a couple of options. And either way, it's going to be the same option, actually. To clean up 1/4, we need to use a reciprocal. And to do that, we're going to simply have to use 4/1. We're going to multiply. And we're going to also multiply this other side by 4/1. Now, put a 1 under that one so you don't get confused. Not that you can get confused with a 1, because 1 times anything is whatever that anything is. In this case, it's going to be 4. 1 times 4 is 4. Over here, cancel, cancel. Everything cancels except for x. And in this case, oh my goodness, it looks like our x by itself is equal to 4. 4th of July. What a great way to go, all right? Now, we always want to check it because we sometimes get a little excited, especially all these 4s appearing. But let's see if it works. Take a 4th of 4, phew, lots of 4, and subtract another 4. Unfortunately, you're not going to get a 4 on the end. Some of you are going like, well, we check out. No, we're going to get -3 according to this, all right? So let's look at it. A 4th of 4 is 1. Let's subtract the 4, equaling to -3. Folks, we are good to go. We check out. Have a little fun. Let's celebrate. 4th of July is here today. Let's celebrate that number 4 while we're at it, okay? Now, I mentioned earlier at the beginning of the show something about quads, all right? Let's talk about quadrilaterals, all right? And here's a short, quick definition here, a very simple definition. A quadrilateral is a polygon with 4 sides. These are 4 sides, they're segments, all right, that hook together and make nice, pretty figures. We love these 4-sided figures. I'm looking at a wall that's made of concrete blocks, 4 sides to each block, all right? I'm looking at things that are going across my ceiling in here. All look like rectangles to me. I've got square lights looking at me. You say, square lights? Well, they're in a square frame. They're really round lights looking at me. But nonetheless, all these things that we look at, they're 4-sided figures all over the place. I'm being surrounded by them, okay? But we're going to celebrate them. How about that? But some of the names of those figures would be rectangles. I mentioned that. Square, rhombus, parallelogram, trapezoid, kites, and then there's just good old quadrilaterals that don't have any specific looking shape, sort of like that rock on that insurance company that you all watch, on TV sometimes. So there's just all sorts of different places where these quadrilaterals pop up, four-sided figures. So what we're going to do, we're going to take a look at them, okay? So let me take away from there just a second, and let's look at our first situation here. First situation is about the square. It says the perimeter of a square, which is a four-sided figure, is 16 inches. Now, what's so cool about a square? We got right angles, and we also have a great little bit of all sides being the same. So if I know the perimeter, guess what? The perimeter is equal to 4 of the same side. So 4S. There's another 4 popping up for us. Great thing. S will represent the length of a side. They're all the same. They're all the same. So in this case, I'm going to put my 16 in because I do know it's just inches, by the way. Perimeter is not square inches. Although we're dealing with a square and we're dealing with inches, perimeter is in just inches or feet or whatever your measurement is. It's the area that we take to square inches, all right? So here we go. We have 16. We have 4. Look what's going to happen, folks. This is pretty cool. We're going to divide 4 into 16, and that square has all 4 sides 4 inches in length. So there's your S. That's each side is going to be worth the same amount. It's another 4. And in this case, it'll be inches, 4 inches, all right? So pretty straightforward. You getting the idea of how today is? Oh, forward, I just said straightforward. Punster, I didn't even know it, They're saying, move on with the show, move on with the show. I know. All right, let's see here. We've got our next figure is a pretty little rectangle. And one side of the rectangle is 12 feet. The perimeter is 32 feet. Now let's talk a little bit about a rectangle. It is 4 sides, as you notice, and it also has 4 right angles. All these little 4s that keep coming at us, all right? 4 right angles there. And with the 4 sides, you notice they run parallel. They run parallel to each other. And this is a version of a parallelogram. It's a special one. It's got all right angles, and it is a parallelogram. And the perimeter is 32 feet. Now it says one side of the rectangle is 12. I'm going to go with the fact they're probably thinking the length here, because that looks longer. And I'm going to put a 12 here. And we're going to say, what is our missing piece right there? By the way, there are 2 missing pieces, right? Because they're the same. They're the same length. So we're going to call it unknown. We'll call them X. Many of you like to call it the width, and this would be the length, all right? But we just said basically one side is 12, so we're going to put it there. That means the opposite side has to be 12, and these 2 guys have to be the same. So let's make an equation happen and make this thing rock, all right? So we've got 2x, that's x plus x, and we're going to add 12. And we're going to say that equals to another 12. Don't leave out. You got to have them both. All right. We're seeing where this is going to go. And that adds up to give us 32. So in other words, I added my 2 widths, my 2 lengths, which is 12 plus 12. And that gives me 24, by the way. All right. So let's see what happens. That's going to give us 2x plus 24 to equal that 32. Uh-oh, looky. We're going to subtract 24 from both sides. That's going to give me 2x equaling to 8. Are you in for it or not here? X equals 4 inches. Yeah, I'm putting a little exclamation point there because this is getting exciting, all right? It's the 4th of July, and we're having 4 for a lot of answers here, it looks like. So put a 4 and a 4 here. Check yourself real quick on this mental check. That's 16, adds up to 32 equals the perimeter. 32 inches there, all right? So, great way to go on this point here. Here is our story. We are in the 4th of July today. And how about it? Let's see. If we do 24 plus 8, you could go either way. You could add these 2 together. All sorts of different possibilities. Guess what? You still get 32. It all checks out. But we're glad to have 4 help us through the moment here. All right. Now, let's keep it going here. We got another great figure. I mentioned the word rhombus. Let's take a look at what a rhombus looks like. It's almost like a square. It could be a square, in fact. But the idea is it's more like the diamond shape on your cards, all right? So what happens here is when these diagonals and the rhombus get together, we get right angles, okay? They also split themselves apart. And the beauty here is that, yes, we start seeing some, y'all see it, right triangles? and some Pythagorean theorem, all sorts of good stuff. I always like just look at a figure when it's done like this. These are not necessarily right angles out here, all right? But I will tell you this. These all guys are the same because a rhombus has congruent sides. They just don't necessarily have to be a square. They don't have to be a square. So that's the catch. If these had been right angles, folks, you got a square, easy problem. Even without the square moment, you still got an easy problem, all right? So it says here the diagonals are 2. So I'm going to go with this one looks a little shorter than this one. So I'm going to let this be my 2. But you know what it says? That says that splits it in half. So this is 1 and this is 1, okay? Now, that's important to notice. This is a 1. This is a 1. We'll try to make them look alike there. This little guy up here, the whole length of this one is 2 times the square root of 3, or 2 square roots of 3 we like to say at times. That's going to kick me a little root of 3 right there and a little square root of 3 down there when I split it, okay? Now, what we're going to look at is this little Pythagorean theorem moment. Some of you are going like, whoa, this is a little bit tougher than that last problem we did, Ernie. Yeah, it is. It is. Just a little bit. Just a little bit. We got to do a little work on this one. But hey, it's Mathline. You got to do a little work sometime, right? So let's go with a squared plus b squared equals c squared. All right? So here we go. Here we go, friends. We got a 1. We're going to square it. We got a square root of 3 that we're going to square. And we're going to look for what is c. C is this little guy out here, all right? And notice some words here. It says, what is the rhombus semi-perimeter? Semi means half. So when we get an answer, we're just going to simply double it. Whatever c is, it means we're going to add another c to it, and we'll have half the perimeter, all right? So let's see where we're going. Let's see where we're going. We got 1. That's what 1 squared is. 1 times 1, right? Remember, folks, when we square the square root of 3, or when we multiply that by itself, we're going to get 3. And here we go, we get c squared, all right? And here we go, that adds 1 plus 3. There's that 4 coming up again. Wow, but that's c squared. That's c squared. So that tells me that c equals to 2. Aha, that's 2. That means all of these are 2. And you know what that semi-perimeter up here equals? 1, 2, 3, 4. It's got it. It is good. It's going to be 4. And this case is, we didn't really even tell you what kind of units they were, but 4 units of sorts there, all right? So there's a little bit more advanced play with this problem, all right? Some of you are going like, whew, are we going to have to work that hard all day on the 4th of July? I'm going to try to make it a little bit easier for you here. I'm going to try to see if we can make this a little bit easier. How many quadrants are formed when we join the x-axis and the y-axis? Well, let's check and see, all right? We pull it around here, and we say, we simply make our x-axis, and here comes our y-axis. And by the way, these things come out perpendicular. There's x, there's y, okay? And these are numbered. These are numbered. So this is Roman numeral 1. This is moving to the left is Roman numeral 2. There's our Roman numeral 3. And here we go with Roman numeral 4. I love it. I love it. Let's talk about the signs of these. In the first quadrant, we're going to be positive and positive. All right. In the second, because you say, well, what do you mean by that? I mean, if I found a point up here, that means that point is to the right and it's going up above. So our signs are both positive, okay, of our coordinates. They're both positive. That might be perhaps a positive 6 and a positive 2. All right, it'd be 6, 2. That'd be how we'd name it, x coordinate, y coordinate. Let's go back this way. How about we find something down in here in quadrant 2. We're going to the left first, and then we're going up. So we're going to be picking up a negative and a positive moment, all right? We're going to be picking up a negative and a positive moment, all right? Now, check out this Roman numeral 3 down here. Put a point somewhere, anywhere we want it. We're going to be heading off to the left, and we're going to be going down. And here we go, negative and negative. Because to the left means we're going negative. Going down is also of a negative variety. So remember, x before y, negative, and then negative, okay? Now, check out our Roman numeral 4 over here. Our good quadrant, number 4, number 4 here, we have, all right, you ready for it, folks? Here we go. We're going to go to the right, which is going to give us the positive, and then we're going down, which is going to give us a negative. Now, people ask a lot of times, what about the axes? What quadrants do they belong to? Well, they don't. They're their own thing. They're their own value, all right? So if I were to look for, example, if I were to look for, how about it, 4, 0, you got it? 4, 0 tells me I would go over 4 and go nowhere. So I would be on the x-axis over here to the right. Okay, we're going to use 4 since that's the number of the day here. How about it going to a point up here on this axis? How would I get there? Well, I'm going straight up. I'm not going anywhere left or right. So if I go straight up, I'm going to be at 0, 4, 0, 4, okay? Now, if I go this way and I want to find the point, or if I want to find, in this case, it's going to be negative 4, 0. That means I go left 4 and I don't go anywhere up or down. And last but not least, coming down here, y'all got it? Where's it going to be? Go nowhere left and right at 0, come down to negative 4. So all these different points and quadrants, a lot of times, like I said, these are important because it basically tells where's the location, and it's also telling us what's the relationship between our x and y coordinates. Are they both positive? Are they a negative and positive? Are they both negative? Or are they perhaps positive and negative? So we look at these, how they work, coming together, as we always do, all right? So, and when we start graphing, it becomes very important that you just remember where those signs are, and you know what, after you do a few of those, it becomes second nature. It's just like playing off of 2 number lines and working together, all right? So, we've got a great moment going there. We've had some other ways that we've seen quadrant, quadrilaterals. How about quick question here for you? See how good you are. I'm going to give you 4 seconds. 4 seconds to do this one, all right? In which quadrant is the point 4, negative 4 located? All right, where are we going, folks? We're going to the right, then we're going down. You guessed it, it's in quadrant what? Quadrant 4. 4. Oh, yeah. And you know what else? There's this other thing that I understand. What do golfers yell as they tee off? Have you ever heard of it? 4, but it's not spelled F-O-U-R, sorry. So this one is a big 4. That's a 4, Roman numeral style. This one is F-O-R-E. I'm sorry, I couldn't resist that one. All right. But, all right. Hey, we got... www. We also love to hear your questions and comments, and we hope you might even send us a few ways of finding the number 4, on Mathline at tnlearn.org. And again, sometimes we use those questions on future telecasts, and we certainly appreciate hearing the comments, the questions, and sometimes you tell me some things there. Also, we've got YouTube going along there, www.youtube.com. And, you probably can Google the number 4 and find all sorts of things on it here. But YouTube has our good stuff that we are doing. Problems of the day now. Many of our problems of the day have gone up throughout the season. And also some of our shows, some of our long shows, our complete long, full-length shows, I was going to get the right word out of there, are also appearing. Let's look at one more quick problem here as we get close to the end of the day. It's kind of taking up a lot of our space, but the theme of the day, you probably already know the answer, but let's kind of work it out anyway, all right? In a trapezoid, it says the area is 24 square inches. So we're going to start with the area. And the 2 bases are 4, and here we got 8 down here, all right? Those are our bases. We're looking for the height. Now, folks, there's a formula that says area equals 1/2 the height times the first base plus the second base. It really doesn't matter which base we call base 1 or base 2. Notice we have these right angles here. These right angles here signify height. Signify the height, all right? And that is telling me that this is the piece that I'm missing, all right? That's the number I'm looking for. So let's do some quick substitutions, all right? Put in A is 24. Half of H, don't know what it is yet, but we'll figure that out. But we can certainly put in 4 plus 8 over here, and that's pretty cool, all right, because that's 12. So let's see. We got 24 equaling 1/2 the height times the number 12. Well, let's go ahead and take half of 12. You know, we can do that. We can take half of 12. We don't have to worry about kicking over here. We could also double 24, but I'm going to just go ahead and take half of 12. And I'm seeing 24 equals, oh, I love it, 6h. And you know where this is going. You know where this is going. What is the height? What is the height? H equals 4. 4. Yes, it is. So there we go. Put a 4 there. And you know what? You have made it through the 4th of July. I hope you've had a great time with us today, and hopefully you found some good uses for the number 4. All right, why it's there. And also there can be a lot of solutions with the number 4. But anyway, we thank you for tuning in today. It is holiday time, and we ask you to be safe with fireworks, safe with travel, and we want to see you back here again tomorrow because we're going to do some other great math works here all the rest through summer school. Still got 4 or 5 more weeks, and then it'll be time on August the 8th. We'll return live. Take care. See you then.